So you guys went through the Graham paper, and I just want to be clear for the record. I actually think that that paper is well done. I think that that paper is a good example of current practice, and it's actually better than most papers that you read in terms of analytic sophistication, in terms of transparency. It is a good example. So despite the fact that you guys read it and found issues, and I think we all agreed it is not reproducible, and there's lots of deficiencies, that is not an attack of David's work or the FDA's paper. In fact, I think it's a testament to how much further we got to go on this journey together, given that this is one of the best examples of a good study, and yet we're all still sitting here scratching our heads about what we're going to do. So what Martijn and I are going to do in the next hour and 15 minutes is show you how we would tackle that study, doing it using the OHDSI framework and the OHDSI documentation, the OHDSI philosophy about how to simplify this problem down. And we're going to break this into two pieces. I am going to take you through the design, through writing a fully specified protocol for this analysis. And then Martijn is going to take my protocol, and he's going to walk you through how to execute that protocol and generate the results. I'm going to design a study in 35 minutes. Martijn is going to execute a study in 35 minutes, and then we're going to have some lunch. So that's your paper. That's what you guys were reading. And you spent an hour debating about the merits of various pieces. Here's how I would frame up that study. What's the T, what's the C, what's the O, what's the time at risk, and what's the model specification? We were looking at dabigatran new users with prior AFib, comparing them to warfarin new users with prior AFib. The outcome, we'll focus on one of the outcomes, ischemic stroke. The time at risk was from 1 day after the cohort start to the cohort end, which in this case was the length of time that they were exposed. And we're doing a 1-to-1 propensity score matched univariable conditional Cox proportional hazard model to estimate a hazard ratio. So this, Scott, yeah. No, please.
On the time at risk, one of the questions that we had is, it seems like a pretty short window anyway, and then not to say that you have to have at least some window of follow-up after index data. Are there issues you might run into?
Yeah, so it's good. So the comment, just for the recording, so the comments is around time at risk. So it seems like using the length of exposure, and it could actually be relatively short, could be problematic, particularly depending on what outcome you're interested in. So you might want to have some sort of other considerations for either other time at risk windows that might either restrict to those people who have some minimal amount of follow-up time, or define a time at risk that wasn't actually bound by the length of exposure, but maybe some just time span from the start of exposure. Or for example, the length of exposure plus some period of time. Or for example, an intent to treat, as Christophe mentioned. So those are all design options and choices that could be considered. In this case, Graham et al. Seemed to have chosen this time at risk. And so for purposes of what we're going to go through, we're not going to provide, that last section was about putting value judgment on whether you like those decisions. Here we're going to simply say, given that these are the decisions, how can we actually design and implement to this? But you're going to see where you would have gotten the choice to make the alternative decisions. Okay, so you guys had to go find the T and the C, and you found it in a blob of text. And so this was the blob of text that you guys were trying to decipher to find out the information about those new user cohorts. What I'm going to do is show you how we can actually implement that in Atlas and have a fully specified definition for that. And let me, Yushi, you're the furthest back. Can you read that? Hard. Can you read that? What's that? Yeah. Yeah? Okay. If things get hard to see in the back, please guys just shout. So I'm here on Atlas. Atlas is our open community. Matt? Can we get one more zoom? Okay. Whoa. All right. Atlas is a really sexy looking tool unless you zoom in 250%. But we'll try our best given the constraints we're working with here. So Atlas is our open community platform. In this tool, we are going to be able to characterize our data sets, define cohorts, and design an estimation study. What I'm going to show you specifically is how we are actually going to first create the cohorts and then design an estimation study using the cohorts that we create. So I am in Atlas. Just so you know, right now I'm running live off of the OHDSI.org website. I sent you guys an email with the link to this thing. I would recommend that you just, for me doing this first exercise, you just watch and just see how it's going to work. This afternoon, you're actually going to get the opportunity to do this yourself. So for the Graham study, I'm going to start with cohorts. So we want to define a target cohort. Whoops, let me get out of this. So I'm just going over here to this left-hand side. I've selected cohorts, and I'm going to, in this particular case, I'm going to go actually select the cohort to see what we've got. And I'm going to do a lot of scrolling with this zoom, but that's okay. All right. So when I want to define a cohort, I need to define make a series of decisions. So one of them first is, what is the initial event to define new users of dabigatran? And in this particular case, my definition is going to be that I'm looking for people who have the following. They have to have a drug exposure of dabigatran, so a drug exposure meaning, for all of you familiar with the OMOP-CDM, so literally a record in the drug exposure table that has a drug concept ID that's going to match dabigatran. And I've specified that that drug exposure needs to be the first time in the person's history. It needs to occur on or after October 19th, 2010. And at that time, the person's age has to be greater than or equal to 65. So this is specifying the initial event cohort. So you're just kind of seeing it in words there. And I'll show you how we can click through to actually build this yourself. From there, I'm going to apply a series of qualifying inclusion criteria like the ones that Christophe showed you on the slide. So for example, we're going to require that they have prior atrial fibrillation or atrial flutter diagnosis, have no prior treatment to the comparator drug, no prior treatments of other anticoagulants, no skilled nursing, didn't undergo dialysis or kidney transplant, etc. For each one of these criteria, that's a statement of words. But every statement of words actually has a formal specification that just looks god-awful. All right, I'm going to zoom back just so you can get a bigger, that'll at least be presentable for purposes of seeing this. So here I'm saying that the people have to have a prior atrial fibrillation or atrial flutter diagnosis. And here what this is actually saying is that that is going to be formalized as logic, is saying a person has to have at least one occurrence of a condition occurrence record of atrial fibrillation occurring sometime between all the days before and up to 0 days after the index date, which represents that first drug of dabigatran. So we're basically using the person's full medical history to look back to see that they have to have at least one atrial fibrillation. Or they have to have at least one occurrence of atrial flutter in that time period, all time before, up to and including day 0. Yes? It's a great question. The short answer is, so the tool allows you to make the choice of whether or not to do that. And I'll show you an example of how you might want to specify if it's a primary discharge from a hospital or something like that. In this particular case, in the study, I'm not sure that they specified one way or the other. I infer generally that when you're looking for just a prior condition, they're probably just using any code. That was my guess based on my reading of the paper. So for each of these statements of words, there is formal logic. We can actually say that when we say there's no prior treatment of the comparator drug, we can formalize that saying there's exactly 0 occurrences of a drug exposure record for warfarin occurring all time before up to and including day 0. We can have some specific requirements, such as no mitral valve disease, heart valve repair or replacement in the prior 6 months, which was mentioned there in the paper. That can be formalized as saying you have exactly 0 condition occurrences of heart valve disease starting with 183 days before up to and including day 0. We can also make sure that there's no procedure occurrences, no observations. So basically think of the common data model and think of each domain as a way to go look for these rules and these logic. Now this set of criteria there are 8 different inclusion criteria, but effectively these criteria are all being applied to the population. So a person who's going to qualify is going to satisfy all of these rules that we create. Yes?
Sometimes saying all days before and sometimes 183 days.
Because David Graham said medical history sometimes, then sometimes he said 6 months prior. And so I guessed and I assumed that when he said medical history, he meant full history, and when he said 6 months, that he meant 6 months. But that's a choice that the researcher gets to make for each of these things. Lou? Yep. Yeah, in this, so there is this button that says restrict to the same visit occurrence, and what this allows you to do is if your index event was some sort of an event that happened in a particular visit, and you wanted to see that in that same visit something else also happened, clicking this restrict to the same visit occurrence will basically make sure that those rules are applied to the same visit. In this context, it doesn't make much sense because the drug is really independent from a prior diagnosis of heart valve. But imagine, for example, you wanted to say you're in a hospitalization, and during that hospitalization, you had a diagnosis of MI and you had a cabbage, for example. You might want to restrict to the same visit to say, what visits did someone get a diagnosis and have a procedure, for example? Yep. Okay, so this formal specification here of this cohort then has finish up there. We have an exit criteria as well. So we've now identified, let me go back to the top. Sorry, this scroll is going to be fun. We have an initial event. Think of that as that's defining your start date for your cohort entry. We have inclusion criteria. These are the subset of people satisfy each of these rules. And then finally, we have an exit criteria. So when does a person leave the cohort? And in this context, in the paper, they talked about that they looked at successive drug exposures, and they tolerated a 3-day gap to basically someone was continuously on the drug. And after that gap was more than 3 days, or they no longer saw records, that they stopped being exposed. So that is formalized here as a exit criteria, whereby we're going to actually define, we're going to basically build a drug era using the successive drug exposure records, where we will specify that those successive records can be up to 3 days apart, and they will be combined together on the basis of these drug records for dabigatran. Okay, so already you can see here that you've got like words. Words turn into logic, but even inside of this logic there are more words. So for example, I'm just saying the word dabigatran, but we still don't have what we need to be able to define that. Inside of a cohort, there are concept sets. A concept set is the set of concepts that define the word that we just used up front. So the word dabigatran is actually the OMOP concept ID 40228152. And formally, I'm actually saying what I want to look for when I look in that drug exposure table is not just this one drug, but I want this one concept, and I want all of its descendants. Because I don't know whether I'm looking for a particular route of administration, a particular form, a particular brand. I want anything that is dabigatran to all be rolled up. Now, you might be, so I've got this one concept and this one descendant, but it might say, geez, I wonder what stuff actually is going to be rolled up under this one idea of dabigatran. And you can actually use the vocabulary to actually observe all of that stuff. So that one idea, dabigatran and all of its descendants, actually expands to 150 different elements within the vocabulary. There are, in fact, just in RxNorm, mainly in the US here, you see that there are branded forms, such as dabigatran, I guess its branded name is Pradaxa. You can see different formulations, whether it be 75 mg or 150 mg. You can see the route of administration in terms of it being or oral capsule. So these are all variants, and all of these might show up in the data. Further still, these are standard concepts coming from RxNorm, but your source data has source codes that might be even something different. And using the vocabulary, we can actually go review all of the source codes. So this particular study was using the Medicare claims data, we can presume that they were principally using NDC codes for drugs. Well, we can actually go, using the vocabulary, we can directly observe what are the NDC codes that define dabigatran, that roll up to that one idea of dabigatran plus its descendants. And so we can see there's, what, 14 different codes. So succinctly, we're able to create a concept set expression, which is the way that we would represent this idea. But once you have that idea, you can actually expand that to get every single code that actually defines this particular population. That concept set then can be referenced, as well as every disease and every other observation, can then be directly referenced. So now I'm able to say, when I say drug exposure of dabigatran, you know that dabigatran refers to a concept set, which then has a set of codes underneath it. I know that's confusing, but is that kind of making sense? Okay.
It might be worth pointing out that that parent concept is an ingredient. And
That's
that-
right.
and
Good-
that
yeah,
the
good
lower
point.
order ones are different dosages and delivery forms and branded.
Yeah, it's a good point, Christophe. Does everybody hear that? We're able to exploit the hierarchy of information in the vocabulary to do this. By picking an ingredient level and saying descendants, we're able to get those more detailed elements. You can use the vocabulary for conditions and drugs and procedures to do whatever you want in terms of finding your higher level idea that you're interested in, and then getting all of the things that are subsumed within that. Now, I've just defined a cohort, and I've defined a set of concept sets. That becomes something that is, there's a couple things that Atlas is going to do to try to help you. One is by creating that, clicking through those and creating that cohort definition, Atlas will then write a human-readable form of that cohort definition that you could then just copy and paste into a protocol. So here you can actually see the language that actually fully describes what your cohort is now that you've made all of those click choices. We can see that it's saying you're people who have a drug exposure of dabigatran, and that little superscript is telling you that's going to refer to the concept set later down in the appendix. So this is basically writing the text to provide you the full specification of your cohort with all of its glory there. What this is also going to do is provide a computer executable form of this cohort definition. So this is actually the JSON expression that we can actually use to basically pass this study around the world and run the study. Or if you just want to run something directly against your database, in every SQL flavor, you can actually just get the code. So this code is generated, and it matches your text, which then matches the choices that you've made. Now, this cohort definition is RT. So we've now just defined a target cohort. If I wanted to create a comparator cohort, it's quite likely that I would want to basically just use the same cohort, just change my target drug to my comparator drug. So just to show you how that would be done live, I could just literally copy this cohort, and this is test for 2017. We're going to make this our comparator cohort, which is what? Warfarin. Just making sure some of you are awake. Okay. So what do I have to do to change this cohort? I'm basically going to go down here, and if I still want it to be a drug exposure, I simply just basically got to switch dabigatran to warfarin. So now I have changed my inclusion criteria to basically switch that from new users of dabigatran to new users of warfarin. I probably want to specify the same other set of criteria because we want our cohorts to be as similar as possible. And then we have to define how are we exiting the cohort, how are we exiting the cohort, and that'll also be based off of warfarin. Okay. So there you go. Once you spend a lot of time defining your T, it takes about 15 seconds to define a C.
Sorry,
Yep.
you've already pre-specified a concept set for warfarin?
Yes. In this case, I was actually quite fortunate to already have one because one of the criteria was can't have warfarin. So it was already in there. Yep. Very good. That's right. What does this say? No prior treatment of the comparator drug. So now we should probably switch that. That should be dabigatran. Good point. All right, so we will make that change. Good catch. All right. We now have a comparator cohort. Now, this process, yes.
Go to concept sets tab,
Mhm.
and there's a column, there's a checkbox for maps.
Yep.
How does it work?
Yep. I'll just get it on the screen. So in this particular case, when you're creating a concept set, there are a variety of different options. The short answer is going to be don't use the mapped column. What it does is it allows you to specify a concept set that's based only on source codes in case you want to do a non-standard study. We're enabling the possibility that some people want to do non-standard stuff, but you are here at the OHDSI tutorial how to learn to do standard stuff, so don't click that.
Can we add new NDC numbers that are not in the vocabulary?
No, so that is a non-standard activity.
We need to add the NDC numbers first to the vocabulary and then use them.
So the issue of how to maintain the vocabulary in that issue is really actually, that's what's going on in that room right there in Christian's class. So all this tool is making use of is whatever is the existing vocabulary that you have within your system. Yes.
And what about doing the other way around, so specifying a source concept,
Mhm.
like ATC code for a bigger thread, and then can you pick that to get the standard concept?
No, so you want to create, you use the vocabulary exploration to actually find the concepts that you want. So very often I will maybe explore something based off of like an ATC, navigate around, find that thing, and then put it in here.
Yeah, I ask because that experience people like in thinking, I see 10 codes in thinking,
Yep.
codes, so they want to type those in and then get the standard.
Yeah, so not covered in this class is how you actually do vocabulary exploration and browsing. I think they are covered in that class. But specifically, just so you all are aware, in Atlas, this vocabulary button, you actually just can click on here and explore all the vocabularies and navigate back and forth to create your concept sets. I have created a T and a C. I am simply just going to quickly show you what our O looks like. Oops, that's right, we did that. So here's an O cohort. Instead of being defined by a drug, we're saying these are people who had a conditioned occurrence of ischemic stroke. And getting to your earlier question, you can see here we specified that it actually has to be coming from an inpatient primary diagnosis position based on what the Graham paper talks about. So in this case, in the OMOP common data model, we have a type field that allows a data source to specify that. So you can see we were requiring an ischemic stroke to be happening in an inpatient setting in either an ER visit or an inpatient visit. Yeah?
So with the definitions you talked about up front,
Mhm.
you mentioned that you shouldn't be using stuff that happens later to define the cohort. And I understand.
Yep.
I understand how outcome is different from target or whatnot. But could this, because you're defining that big gold circle,
Yep.
which has a lot of folks outside those two analytic T's and C's, could this influence how you define your analytic T's?
So it's a really good question. So the conceptual issue is we're defining this outcome cohort O, and you can see that I'm just finding all the strokes in the database. We do this very deliberately for a few different reasons. One of the most succinct one is because when you define an outcome like stroke, that is independent of exposure. How to define stroke has nothing to do with whether you're thinking about warfarin or dabigatran or some other drug. And because it becomes a standard cohort definition, once I've defined ischemic stroke for this study, I now have defined ischemic stroke for all studies. I now have a definition of ischemic stroke that could be applied to any T and C that I wanted. So that's very important. To answer your question, like, does this influence what's going on with the T and C? You'll see when Martijn's executing the code that we will do things like, for example, you might want to exclude a person from T or C if they've had an O prior to the event, but that's going to actually be done by the model, not by the cohort definition. All right.
Patrick, I have a question
Yep.
back here. So it would work this if we threw it out to the network, we would be limiting it to data sets that have the attributes of that, like those very specific types of condition types. Right?
Yes.
We're kind of being restrictive and who we can pull data from. It doesn't, like, yeah.
Yes, it's a good question. So right now we're going through the exercise of replicating David Graham's study. David Graham's study was done in a Medicare claims data set, so his worldview was claims data. This is a way one could do that if your world was claims data. We are definitely not advocating that this is how we would do a network study. We're just showing you how to do David's study. But it's a very good point. One of the restrictions would be any of you who have access to a database, but maybe you have an EHR, you might run this cohort and get 0 members back. Not because it's not a valid definition, but because you don't have the specification of inpatient primary discharge claims. You have an EHR problem list, which would not be in this list. Good question. Okay, so I just showed you a T, a C, and an O. Now I'm going to design the study in how long? 5 minutes? Do it. Do it. All right, so I'm switching over here to estimation, and I'm going to open up the Atlas form for an estimation study. I think. Whoops, let me close that, sorry. Graham. Okay, so probably unsurprisingly, you're going to find that you're going to be asked a series of questions that are going to follow what you've been hearing this morning. In this template, what you are going to see is that it's going to require you to make user choices of what decisions need to be made. It's going to ask for you to select your target cohort. So you basically just click over here and go find the cohort that you wanted, dabigatran. You just select your cohort. It'll ask you to choose a comparator cohort. It'll ask you to choose an outcome cohort. It is then going to ask you to specify the statistical model that's going to be used to estimate the risk of the outcome between the target and comparators. So you'll be able to choose whether you want a logistic regression, a Poisson regression, or a Cox proportional hazards. You're then going to need to define your time at risk window, which in this case is 1 day from the cohort start, so basically the day after they started dabigatran, all the way to 0 days from the cohort end, being the length of exposure in this particular case. Of course, those are choices that the user gets to make right or wrong. And you can see that you could have specified a defined period relative to the start or some infinite period of time if you wanted to, but Graham et al. Chose this one. You're then going to make a series of other choices about how to handle the analytic considerations. So for example, do you want to have a minimum washout period applied to both of the cohorts? Do both cohorts need to be in the database for some period of time? Do you have a minimum required days at risk? So do they have to have at least some time to be used? What do you do in that case of that Venn diagram I showed you where there are people who are actually in both cohorts? Do you want to just remove them, or do you want to keep them and use them in some way? What do you want to do when there's a person who has an outcome prior to entry into the cohort? So this example of if they've had a stroke before they started warfarin, what do you want to do with that person? You want to kick them out, or do you want to keep them and consider them in some way? Do you want to use propensity score as a confounding adjustment strategy? These are all choices, and Graham et al. Chose yes. Once you choose that you want to do a propensity score, I guess I'll just flip this over here. So you could have said, no, I'm not going to do propensity scoring adjustment. But once you do say yes, you're then presented with another layer of questions, which are what covariates do you want to use in your propensity score? And you have various choices of demographics, conditions, drugs, procedures, measurements, risk scores, density of how many concepts are in the data, interaction terms, whatever you want. In this particular case, we've selected some of the variables that David Graham has picked. Yes?
Are those standard, or are those based on the cohort definitions and the concepts that you defined for the study?
It's a good question. So these covariates, so Martijn has actually authored an amazing package called feature extraction, which we'll only kind of touch on. Well, you'll see pieces of it in the code. But effectively, we have created a very, very large universe of covariates to choose from, and you have the ability to add custom if you're not happy with the million options that Martijn's already given you. As a general practice, what we've been using is we just select everything and let the lasso regression actually make choices. But what David Graham did was he defined a set of covariates, and in this tool, you can actually just create a concept set that says, what covariates do you want to include? What covariates do you want to exclude? And you could massage it down to your hand-picked 20 variables if that's what you want to do. but we would say that you don't necessarily need to do that, and you might not want to.
So that means that this is specific to this, the study set that you've already done. You're going to get a different list if you had made different choices earlier.
That's, no, so what I'm making the choices here, this has nothing to do with those cohorts. So I'm just choosing covariates at this point. They're not bound by those cohorts at all. The cohorts was just a set of people who satisfied the criteria. Christophe.
In the regression model, do you have those other outcomes stuck into the right censoring somewhere in that definition?
So in this particular study design, we are removing people who have had the outcome prior to cohort entry, because they would not be at risk for a new event if they've already had an event. But given that, so those people are removed. I see what you're saying. For what we're showing here, we're focused only on one outcome, which is ischemic stroke. So if you want to, yeah, so if we wanted to, I won't go back to it, but in the cohort definition, you can actually add censoring events into your cohort. So basically, they could stop at a certain point if you wanted to do that. We didn't in this case because we're just going to focus on this one outcome. Yep.
In this scenario, we decide we keep those patients who enter both cohorts, right?
Remove patients who entered both cohorts. So yeah, so that should be yes. Yep.
So in the scenario, we clearly know the algorithm will take those patients, the same patient differently, but the same patient could have different age because the next stage could be different.
So if you do not remove people who are in both cohorts, then that same person will belong to both cohorts and effectively will be treated as if they were like two independent people, and basically be used as general. I don't think we actually have anything written about it, but in general, what we've been doing for studies, we generally remove the people that are in both cohorts. We have to be careful. We have to be careful about having the same person. It introduces some messiness. Yes.
In the paper, did they censor patients who went from warfarin to the
Yep. So that could be another sensory thing that you could put in. Yeah. So if they.
would not remove.
Oh, good. Yes.
They were excluded, I thought. They specified that the cohort would be stopped at the time when they're leaving.
But they're still in.
But they are in.
Yeah. That's a good point. Yeah. So as choices, you can define, when someone gets censored, when are they in and when are they out, and you can make those choices however you would want to. Yeah.
If you have a linear justice, I'm sorry, I'm asking the same question again. So if one wants to add additional baseline covariance,
Mm-hmm.
how do we go about that?
So if you want to create your own custom covariates, you are not going to use a standard user interface with click boxes because you're going to need to write code to create your custom covariates. I don't think Martijn's got it in his code, but he can show you where, if you just write a little bit of extra R code, you're going to be able to actually do that. If you can be limited to the 150,000 options that we have, then what you're going to have the opportunity to do is make use of just a standard framework. What that's going to allow you to do, give me 1 second and I'll get there, is make these choices that will allow you to define your protocol without actually needing to write down that specification of those custom things in words and in code. So a value of this is that now that I've made my choices, including propensity score matching with one-to-one matching, what this will provide you now that you have made those design choices is the tool is going to provide you your print-friendly protocol. So it is now just written for you. Here is your research question based on the choices that you have made. Again, framing that instead of you writing the question and then hoping that the analysis matches it up, we're using the analysis to tell you what question you're actually going to be answering based on this. And then from there, you're getting a study design description that has all of the design choices that you need to make fully written into this human-readable form, albeit kind of wordy. This describes not only what the study design choices are, but what would be the standard output that you should expect to get given that you are doing this standard approach to performing the analysis. So it's going to describe what kind of diagnostics are going to be generated, what kind of outputs. And then it's going to provide you all of the appendices, which are all those cohort definitions for T and C and O, all the way down to all of the individual codes. What this tool is also going to allow you to do is not only is you have human specified the study and you now have your protocol, but the tool is actually also writing completely the entire R script so that you can now execute this code. So the full R code for doing the study has now been written for you. And it's a lot of code because it's a lot of analyses that we're performing. But this code can be directly executed in R. And I'm scanning through it very fast because what Martijn is going to do is actually walk you through what that code actually is doing under the hood and what the outputs would be now that we've designed this study. One last thing I'll do before switching it over to Martijn. Importantly with all of this, this is a fully specified transportable object within the OHDSI community, meaning anybody can design an estimation study anywhere and share it with anyone else. What Marc and Martijn have actually been leading for our community is figure out how to do this in such a way that we can create a 100% fully reproducible object that can then be preserved and passed around. Atlas is a great tool for doing design. When it comes to network studies, there's a little bit more work that goes into that. But for a design component, think about this as making every decision you need at this level of specification that you have a protocol that states everything you need to do to the point that a programmer could program it because, in fact, the code would be generated directly and 100% consistently with the choices that you've made. So let me, Matt?
There aren't options for the propensity score model, right? It's a lasso regression?
Yes. In this user interface, the only model that you get to currently choose is a lasso logistic regression.
And Graham didn't do that, though, right?
So yeah, so he did not use lasso. He had a defined set of variables. That's right. Yep. Any other questions? Yes?
Can you export it as JSON like you did with the cohort definitions?
I'm sorry?
Can you export it as JSON or some form like that?
Yep. So this right here, this export, this is actually the JSON object for the whole study specification. All right. So we've just designed a study. We've written a protocol. And now we're going to execute it. So Martijn is going to show you how that actually works out.